I have a fair bit of material to cover and obviously a fairly short amount of time to cover it in. So I'm going to jump right in. Hopefully you're all able to see my screen right now. I'm assuming I would have waving hands somewhere if it wasn't showing up. So I am going to jump right in to our agenda for today. So I'm going to give you a quick background on the building at 255 Riverside Drive, which is in Windsor, Ontario. We're going to talk very briefly about why EnerPHit and why Stepwise for this particular building. I'll run through the planned Stepwise retrofit sequence that we have for this project. And then I'm going to spend the bulk of my time tonight talking to you a little bit about our phase 2 construction challenges. So some background on the building. This is 255 Riverside Drive. It was constructed in 1975. It's a 20-story building. It has 303 residential units and it is fully occupied. The cladding of this building is TTW brick and it has load-bearing concrete shear walls that are exposed. In about 1985, so roughly 10 years after construction, the vertical metal siding that you can see on the one elevation and at the top of 3 floors of the building was installed. And this was done to address some really early onset deterioration of the TTW brick. Each of the suites in the building does have a cast in place concrete balcony, and those balconies are cantilevered to the structural slab. And the existing windows and balcony doors were single glaze set in aluminum anodized frames. The heating system for the building is electric baseboard heaters, and cooling is actually through wall mounted units that are just plug and play AC units. You can actually see the line of them running up the image that I've shown there. Some units have them installed, others don't. Some units have big, giant, gaping holes where they've maybe stuffed a bit of newspaper. Not the best method for sealing, certainly. The exhaust in the building is ceiling and wall-mounted fans in all of the suite bathrooms and kitchens, and the makeup air is fairly typical for this building typology. It's a continuously operating supply into the corridors. There are boilers on site that help to heat the makeup air and the domestic hot water. So why EnerPHit? We'll start with why EnerPHit. Well, the owner of the building, Windsor Essex Community Housing Corporation, has already gone through and really tried to capture a lot of the low-hanging fruit in their portfolio of properties. So what that means is they've gone and done little things here and there, like lighting upgrades or other energy efficiency retrofits or even water-saving retrofits that are relatively easy for them to implement. One thing that was a big driver for this project in particular was that a lot of funding is available for energy and greenhouse gas reduction projects in Ontario right now, particularly for social housing buildings. And as long as you can show those savings are going to be in excess of 25%, you typically are eligible for that funding. The client really felt that Passive House was a proven standard. They actually have one new construction project that's also currently underway. And that was something they were really looking for when trying to address deep energy retrofits in their building and looking at a way to sort of set up this almost as a pilot program so that they can then apply it to many of their other properties. In this case, the building is located at a really desirable and strategic location. You can see in the photograph there, it's on Riverside Drive, it's right on the river. You can look across and see the US from this building. And I can personally attest to the fact that the views of the firework displays that happen over the river are pretty spectacular. The building has really good bones, but a number of the significant components were starting to reach the end of their useful service life. The little table I have there just shows a quick excerpt from one of the building condition assessments we did, and you can see the windows and doors, the makeup air unit, the exterior walls. They were all reaching that point where some sort of major intervention was going to be required. So when the client looked at this and looked at, the amount of work they had to do to the building to retrofit versus what they would have to pay to create a similar building elsewhere, it was quite a bit lower cost, obviously, to do the retrofit at about $69 a square foot versus the new construction, which they anticipated would cost them in the neighborhood of $237 a square foot. So why go stepwise? Well, the Stepwise approach allowed the building to pursue certification within their financial constraints. And you can see a quick breakdown of the sort of main 3 phases of actual work at the property. So the balcony doors, the HVAC, and the envelope and insulation work. And you can see there's a number of different things there. So CHC is the client themselves. So what was coming from their budgets for retrofit and renewal. And then each of the other columns is actually a program that they were eligible to receive funding from through the government for repairs and renewals, or energy saving projects. So they really were dependent on a number of different programs, which each had a different set of timing for when that funding would be released. So essentially, as was sort of well introduced before this presentation, this stepwise approach allowed them to plan all of these retrofits in a way that made the most sense for the building and also allowed them to work within those funding constraints. The other part of it was, obviously, the building is occupied. It's really just not feasible to do all of it in one shot. And as I'll talk a little bit later, you'll see how even just one aspect of the project had a pretty significant impact on the lives of the people living in the building. So what were the retrofits? And you'll see here, I've got just a quick little shout out to our project team. So obviously projects like this and of this scale don't come together easily and don't come together on any one person's effort. This took a pretty dedicated and significant team of experts to address all the challenges that we're going to talk about today. But the first phase of this project was a sliding patio door replacement. And this actually took place before the project team became involved. The client, knowing that they were planning to pursue either Passive House or EnerPHit in some way, shape, or form, did actually plan the project well, and they included the use of a Passive House certified patio door. But that part of the project was done almost as a pilot in advance of even completing the full EnerPHit feasibility study. The second phase is the mechanical systems installation. That phase of the work actually just achieved substantial completion probably about a couple weeks ago, like mid last month. We're still working on tying up a few deficiencies and completing some testing, but the bulk of the work is finished at this point. Phase 3 and 4 is going to be the building envelope, the walls and windows. So that'll be overcladding and replacement of all the remaining windows at the site. And then there's a number of pieces of future work that are going to take place a little bit further out, typically at the end of the service life. Those were originally planned to be the domestic hot water pipe replacement and insulation of those lines, and elevator upgrades and a roof replacement. Now, because of some changes to the plan, the elevator upgrades are actually underway as we speak. So that project now has moved forward slightly from their original plan. When all is said and done and all of this work is complete based on the PHPP modeling, we're looking at about a 65% savings in total energy for this building. So we're going to talk about construction challenges. This is where some of the interesting things about dealing with an existing building and certainly dealing with an existing building with people living in it come into play. So the first point I'd like to talk about is essentially extensive access being required into the tenant spaces. So we had about 10 key tasks identified, and they're listed on the screen there: demolition, electrical, cutting for fire dampers, corridor ducts, unit ducts, pressure testing, insulation, drywall and bulkheads, and then like millwork, painting, finishes. Each of these required access into the units at some stage in this project. So how did we handle this? How did we sort of manage this process? Well, a detailed matrix was developed identifying each of the units and the 10 tasks, and systems were put in place by the contractor and by the ownership team to make sure that notices were being delivered to those units in advance of entry within accordance of CHC's policies and requirements. Management of the suite accesses, notices, delivery, tenant interactions was actually a full-time job for probably at least one staff on the contracting side, as well as one staff on the ownership side. For something like this in the future, out-of-the-box thinking would really be required to try to develop a better system for construction sequencing. The typical sequencing where we had sort of one set of crews go through and maybe complete a floor before moving to the next floor, and then there's maybe a lag before the next crew comes in doing another piece of the work, and a lag before the next crew came in, resulted in what you can see at the bottom there. So we had some units in the example of this task matrix shown where we were accessing their unit in September, October, November, December in 2019, and then again in February 2020. And those aren't even the worst of them. We certainly had some units where we may have accessed them in October or November of last year, and we're still accessing them this summer in order to finish this project. In an ideal world, it would be great if you could enter that unit, do all of the work there until the full scope is completed. But when you start layering in things like balancing and testing requirements into it, that becomes really challenging because unfortunately those tests have to happen when a larger section of the system for the mechanical equipment is complete. So for example, we can't insulate until we've pressure tested the ductwork. So we couldn't really find a way in this case where we were able to make that flow where we could just enter their unit for a couple of weeks and then be gone and finished with them. Another issue we found early on had to do with space. That was one of the things that we sort of had at our forefront at all times. So I've got two issues here to sort of highlight that. The first is the hallway ceiling clearance requirements. So our design actually had to be down to the millimeter in order to make sure that we were able to meet the Ontario Building Code's requirements for ceiling heights in the corridors. Now, this basically meant because we were installing ductwork through these corridors, we had to design very specific specialized flat bar supports for our ducts. Even just using a standard duct support at the minimum size that it's readily available in was putting us over. And you can see in the sketch, the hand sketch there, we actually had measured out and planned out down to the fraction of a millimeter. And when all was said and done, we had about 5 millimeters of construction tolerance available for this detail. One of the things that we highlighted with something like this in future projects is that we really should have constructed a mock-up right at the outset prior to starting the project. We did do mock-ups once they were mobilized and as we were working through these details, but we had a few conversations with contractors initially, but I think taking it that next step further and actually having a section of this installed at the outset would have been very beneficial to our scheduling once the project started. The other aspect of this was just in general lack of space for mechanical equipment. So in this case, we actually converted 4 units to mechanical rooms to house the ERV units. And we also had a loss of closet space in many of the units to create things like risers to house equipment and for other ductwork. Now, one of the things that sort of worked in our favor in this case was that at one point during feasibility, the client was told that they could potentially need to lose as many as 12 units. So when we put our schematic together and came to them and said we could do it with only losing 4, they felt like that was a great deal for them. We may not be so lucky next time. I think if they're expecting 0 and you tell them 4, they may not be quite as amenable to that arrangement, but in our case, it worked in our favor. One thing that's really critical with this, obviously, is to discuss potential space implications with the client at the outset. Because we were taking away closets in some of these units, we had to arrange to purchase freestanding clothes hanging units that were installed and supplied as part of this contract into those units where closets were being lost. That can have a pretty significant impact on someone, particularly in a social housing unit where there's already not a lot of storage space, so it kind of comes at a premium. So it's definitely something to bear in mind at the outset. All right, so I mentioned that we took away some closets for running risers. That created a pretty interesting challenge for us. So in order to create those risers, obviously we had to core through the existing floor slabs. And one of the things that we ran into was a lot of embedded conduits. Now, we had done our due diligence as best as we possibly could at the outset of this project. And the first image you can see there is actually markings that were set up on the floor based on a scan we had done of the slab trying to locate embedded conduits. Now, even at the units where when we completed our scan, it seemed like there were no conduits anywhere near where we were going to be cutting, lo and behold, we start cutting and we hit conduits. About less than 10% of the scan results were actually accurate for us. Now, one of the things that we did consider as a different type of scanning, like something like an X-ray, likely would have been more accurate. However, there's a lot of implications with doing X-ray scanning in occupied buildings. And at the time, it really just didn't, the benefit and cost didn't seem to work out from the client's perspective. So we implemented a couple of things for safety, obviously. We utilized a special piece of drilling equipment that was attached to the core drill. And it actually was designed so that as soon as you were about to come in contact with any live wires, it actually shuts the drill off. This was a huge, huge benefit on this project and made a big difference for us. In hindsight, if we had known how significantly unreliable the scanning would have been, we probably would have structured the project a little bit differently to actually cut the power to the floors and complete the rewiring first around those locations and then complete the core drilling once that section of wiring was disconnected and abandoned. We also ran into a few issues of puncturing existing water pipes in some of the walls. And this was basically where we were penetrating our ducts from the units into the corridors. Now, we did use IR scanners to try to detect any hot water pipes in those locations, but we found that those types of scans don't necessarily locate everything. Things like cold water lines or existing ductwork or other existing out of service conduits don't necessarily show up when you try to scan. So in those locations where our as-built construction drawings were not particularly reliable and the scanning was not really picking up on some of the things that we were finding, we identified those riser locations, and in those places we made the adjustment to shift the penetrations over the doorway. And that basically helped us to ensure by going over the doorway that there wouldn't be any existing services in that space. It did mean reconfiguring some of the bulkheads and ductwork inside the units, but we were able to do that in a way that was still visually appealing. All right, a next challenge that we found, which is somewhat common in existing buildings, is in some of the areas where we had opened up drywall to run our ductwork, some of the existing electrical wiring didn't actually meet the current ESA standards. Now, technically, we weren't touching this wiring. We weren't running any electrical in there. We weren't doing anything to it. It was existing. It was remaining existing. It was completely outside of the scope of our project. Unfortunately, the ESA inspector, when they came by and saw it, identified a couple of things that they felt were safety hazards. Because they felt they're safety hazards, we weren't able to basically sit back on our laurels and say, well, you know, this was how it was built and it met the code of the time. That's not really the case. Obviously, if there's something that's a risk to safety, they would like you to address it. So we ended up having a change order, obviously, on the project, because this is work that we never would have expected to have to complete, where the contractor had to make some adjustments to how the wiring was supported within the ceiling space, anywhere that we opened it up. So just be wary, obviously, of defects that are exposed, but outside of your scope of work. That's something in an existing building that can kind of pop up on you that maybe you weren't planning on having to deal with. Next was an issue we ran into with duct air leakage testing through fire dampers. So one thing we found was this building, obviously, we had to use a lot of fire dampers. We were creating essentially new penetrations through floor slabs, through fire separations. We were creating new penetrations through wall fire separations from the unit to the corridor. So obviously that meant lots of fire dampers. One thing that we found when we went to do pressure testing of the ducts was that particularly the fire dampers, when we were testing the runs for the vertical riser, because they're basically every 7 or 8 feet, depending on the floor to ceiling height, they were having a pretty significant impact on our testing. And the fire damper manufacturer was not very comfortable at all with us testing these fire dampers via the pressure test the way that we were hoping to. Our solution ended up being that we took the measured air leakage of those duct runs and we subtracted the manufacturer specified leakage through the dampers to basically try to remove whatever the extraneous leakage we were going to be seeing that was occurring as a result of things like the damper arm and some of the other penetrations that are required as part of the fire damper. Going forward and in the future, we would probably try to look to have some discussions with the fire damper manufacturer that's being specified, or even at the shop drawing phase, to sort of more clearly lay out with them what the requirements are going to be for that testing and ensure that the product that they're planning to use for the project is going to be able to meet the testing requirements. So the last one I'll talk about today is tenant interference with the ventilation system. So this is actually a really interesting issue that has just popped up over the last 2 months, I would say. So we have our wonderful system, we've installed our ductwork, the grills are on, the machines are installed, we've started to commission them, and it's time to do air balancing. Well, lo and behold, some of the residents are maybe not so keen on their new ventilation system and maybe don't fully understand the purpose of it or how it works. And what they've done, as you can see in the photographs, is they've gone through and they've actually covered the new vents, the supplies and the extracts, with paper or tape or fabric or other pieces of plastic or cardboard, all kinds of different things. So obviously what happens then when we try to balance the system is we're getting units where we're finding a significant variation from the design CFM to the final actual measured CFM. We made a lot of efforts and worked really hard with the client and the representation on site. We had the contractors enter these units, remove all of the coverings off of the vent, and basically speak with the owners one-on-one, or the tenants one-on-one, to say, you know, this is why we're doing this. And despite that, many of them advised, as the contractor was walking out the door, basically, as soon as you leave, I'm putting it back. So it puts us in a bit of a pickle where, you know, we're trying to get this balancing complete. We're trying to do it for an entire run of floors on an entire wing that's serviced by one mechanical unit. And essentially there, you know, we can go in the unit 1 minute and 15 minutes later, it's covered up again. So what we had to end up doing was speaking with the certifier about this. And what we agreed upon at this point in time was flagging the units where we're having tenant interference on the reports, and making sure that we're including photographs of the blocked vents for submission to the certifier to basically identify the locations where this has been a problem. One thing we're actively working on right now is we're trying to work with the client on completing some additional education for the tenants on the benefits of the system. Some of the feedback received is that, you know, they don't want bugs crawling in, and, you know, they don't want cold air blowing on them. So certainly a little bit more information would be helpful. The other challenge that we found at this building actually is that for many of the people living there, English is not their first language. And so as we're trying to explain to them the purpose, or explain to them what we're trying to do, there's a bit of a language barrier there. So one of the things we've talked about is considering offering the materials in multiple languages, or even having representatives from the client side who are fluent in other languages to sort of help offer some additional education sessions for people who are having difficulty sort of understanding what we're trying to communicate to them. So that pretty much brings me to the end of the presentation. I guess at this point, we're going to open it up and take some questions.